Your homework tonight involves angles that are not in the center of the circle, but are rather pulled back to the edge. Here we see in question number 1 a very basic example of this. A central angle would look something like this, where we see the red angle starts in the middle of the circle and comes out to A and B. And in this situation, whatever x is, then this angle would be exactly the same. But what we see instead is when the angle is pulled all the way back, it's 60 degrees. So the theorem we discussed in class says that if an angle is pulled back, it gets smaller and smaller and smaller until it is half of the arc that it forms. So in this situation, when the angle was pulled back, it got smaller and smaller and smaller until it was 60. And so we ask ourselves, 60 is half of what value? We can figure that out by multiplying the number by 2, and we realize that it must have been 120 degrees before it was pulled back. And so that would be the answer to this question. The next theorem that we learned involved quadrilaterals, where every angle is a pulled back angle. And one of the rules here is the opposite angles in an inscribed quadrilateral have to be supplementary, meaning they must add up to 180. So here, the 150 on one side leads us to realize that this y must be whatever makes that value add up to 180. So we can do 180 take away 150, and we're left with 30. So y must equal 30 degrees. We can do the same thing for the other one. The 110, of course, is across from the 2x, but we do need to solve for x here. So we'll do 180, take away the 110, we're left with 70. So I know that 2x is equal to 70. And if 2x is equal to 70, in order to solve for the variable x by itself, I'll divide by 2 on both sides and have x is 35 degrees. I didn't have to do that in the last problem because the y was already by itself.